And we had some disagreement about the eye stalks and the lower stalks that are for tasting and smelling. Not everyone in the class was sure what those were, and we had some differing ideas. So we used a text to help round out our thinking. And that was really useful. And this example is an informational chart that was constructed together as a class. And I just want to point out that this shared writing piece could be a springboard to develop student skill in informative and explanatory texts. If it, in this kind of writing, students are using an authoritative or teacher voice to teach the reader something about a topic. And students could either use snails as their topic, or the teacher could model using snails as a topic for a writer's workshop mini lesson, for example. And then they could identify aspects of snail structure and behavior that they think readers would be interested in. And if students have multiple opportunities to observe, even round out that observation by reading about snails, doing their own investigations with snails, they can plan an informative text of their own, asking themselves questions like, what do I want my audience to learn? What will interest people about snails? What might confuse them that I can clarify? And so if you can advance to the next slide, I'd like to show you an example of narrative writing with older students after a similar experience in observation and investigation. A lot of you mentioned, in fact, I think Glenda talked specifically about shared experiences, bringing background knowledge. And that kind of shared experience can really be mined for narrative writing. In the upper grades, one strategy that the teachers I work with use in writing is to make a mental movie and to tell the reader what happened bit by bit. And that's the strategy that this piece of writing was used. And it could be used as a model. A writing sample like this could be used as a model the teacher shares, as maybe a mini lesson on how can we add more details that don't tell the reader what happened. Maybe we describe more actions that took place, or more sensory details, or maybe we describe images. For example, students could take that first sentence and revise it using details from their own observations. How exactly did the snail move? Can we describe it in more detail? And I think in our virtual setting, this kind of writing mini lesson could be done interactively during a class meet, or teachers could tape a mini lesson video that students watch and then revise this piece of writing asynchronously. And then one last comment I just want to make about observation in science and in writing is that we really know that using visuals in informational or narrative text or any kind of student text is a great way to spur more detailed writing. So after a piece of writing like this, or before or concurrently, students could add to or revise diagrams to text pieces like these, which often has a cyclical effect where it helps them remember more details as they're drawing the images, which usually leads to adding more writing. And that can be a really useful strategy. And I just wanna, I want to comment, I see Brian's comment there. We want to assume, we want to bring everyone to the same playing field. So an experience like this is really nice, a shared experience, because all of the kids have an experience that they can use to hook on and access the learning. So when we did this, Kelsey, could you put the next slide on, please? When we did this with the kindergartners, the close observation raised a whole lot of questions, and we as a class chose one to investigate further, which was, what foods do snails eat? And the kids brainstormed all kinds of different foods they wanted to test, and then I brought in a range of them to test. And we did that in person, but it could be done online in the way that Fred and Kelsey did with you earlier today. We had a mat with each student in a table group of 4 would share, and each student got to choose a food item and put it on the mat, and then that mat had little circles in the middle where the snails were placed. There were 2 snails per mat. And then we had some class discussion around how were we going to tell if a snail ate a food? And the students decided they wanted to see if the snail's mouth was moving when it was on the food, or if there were bite marks on the food. And then each time they saw evidence of a bite, they would put it back in the starting point. So you could do a more formal investigation like that with your students. You could do it a little less formally, like how Fred and Kelsey did. There's lots of options for what would work well. And I'm just trying to also keep track. There's a lot of comments going on here. And I just really want to support what Danielle says about the engage activity and engaging their interest, because when the students are interested in the topic, they're so much more willing to engage in rigorous writing, rigorous mathematics, rigorous science. And it's really, that student engagement really builds with student interest in a topic. And we will share information about where to purchase snails. Yeah, and the idea, especially with older students, is that they don't all have to investigate the same question. There could be different investigations based on different questions that are interesting to the students. And that, again, connects to student engagement and interest. In our particular situation, not all of the students were readers. This was like September in a kindergarten classroom. And actually, not all of them had one-to-one number correspondence. So we had a number chart where the students checked off the next sequential number so that they could keep track of their quantitative data in an accurate way. Older students certainly could be engaged in a class discussion about what data are we going to collect and how are we going to keep track of it. When the students were done, we asked them to use those number charts to circle the food item that the snail visited the most on their chart. And then they brought those charts to a science talk where we built a data chart together, and using the pictures of food from their own mats. So maybe we can switch to the next slide. We then built the chart with the students so they could see how each group's data corresponded to the data on the chart. And we used a simple T-chart, foods that the snails did eat on the left and foods that the snails did not eat on the right. And then the food that the snails ate the most in each group was first in the column. And so this was a nice, more qualitative way for us to look at the data. And it was really important to look at this data as a group, because what one group found was not necessarily the same as what it wasn't mirrored by all of the class data. We really needed to look at all of the class data together to get a clear picture that snails eat many, many different types of food. So that's, again, in a virtual setting, something that you might want to engage in an investigation like this at least 2 or 3 times so that you can collect multiple data points. Older students could discuss how this class data should be organized. And in fact, you could have small groups of students working together to organize this data in various ways. And you could have some really interesting class discussions about how does organizing data in different ways help us interpret and analyze it. And I want to just spend a little bit of time on this data, because I'm taking a class right now from Jo Boler, who's a professor at Stanford, and some of you may be familiar with U-Cubed. She's someone that's really helped my teaching a lot. And she's also one of the folks that is revising the mathematics framework, which is going to come out next year. And one of the things she's told us is that the entire math framework for California is going to focus on 2 types of mathematics: number sense and data analysis, or what she calls data science. And she's really stressing upon us that students should be regularly working with data sets that are meaningful to them. And one of the things that's become so clear is that science provides a shared experience and a meaningful data set that helps kids with this really important aspect of mathematics. And one of the things that's been really interesting in this class is that Jo has long been a proponent of number talks, and now she is suggesting that teachers add data talks to their mathematical tool belt. And she suggests the questions, what do you notice? And what do you wonder? As really great scaffolds for a data talk. And in fact, we use those questions with kindergartners, and I'm convinced they would work equally well with fifth graders. It's just a wonderful way to invite students into looking closer at a data set and really trying to understand, what is this data? How can we analyze it and interpret it in a way to make sense of it? And what questions does it raise for us, so that maybe we can investigate a little further, or maybe we want to do some reading. In a way that's really helpful to students. So I just want to, thank you, Maria, for sharing a little bit more information about Jo Bowler. And I just want to, I think there's some points here about, oftentimes we don't know what students' background information is on a given topic. And so, we certainly don't want to make assumptions, but we certainly benefit students when we can provide experiences that all of them can engage in and access. So I really appreciate those comments.